Hello everyone, and welcome to the first of 3 videos where we are exploring the 2-dimensional array. So in this particular video there's no coding or programming because I wanted to create a brief introduction to 2-dimensional arrays where we really focus on how to best picture or visualize a 2-dimensional array. In other words, what is this thing that we're working with in our code and what does it actually look like? But also to understand the way that Python constructs a 2-dimensional array. In other words, the syntax that we need to work with in order to build a 2-dimensional array for us to be able to use. It's really important that we bring these two metaphors and concepts together so that you are as confident and as comfortable as possible knowing what 2-dimensional arrays are and being able to picture them in your mind when you're doing your coding solutions, particularly if you want to take on some more challenging code or some more challenging projects that involve a greater use of 2-dimensional arrays. So with all of that in mind, how do we best picture a 2-dimensional array? What is this thing that we are required to work with? Well, the best way to picture a 2-dimensional array in actual fact is a table, and you're very familiar already with data that's presented to you in table format because essentially that's what a spreadsheet does. So if you have a look at the example on the screen, we could represent this table using a spreadsheet, in which case we would say that some of the cells in our spreadsheet would be empty. You can see empty cells on the slide, and you can also see that we have got some whole numbers or integers that we would want to put into our table or spreadsheet as well. Now you'll also know that in order to work with one of the particular items or values in our table, we need 2 pieces of information. We need to know the row and the column. So let's put some imaginary row numbers and column numbers on our table. So from 0 to 3 for the columns and 0 to 4 for the rows. You will know that with those, with that information, we can find where value 4 is in our particular table. So we could say that value 4 is at a particular position in our table because we know the column and the row. The question is, which way round do we express this? Where is 4 in the table? Is it at position 3, 2, in other words, column 3, row 2, or would we say it's at position 2, 3, in other words, row 2 and column 3? So at this point, I want to introduce something really important which you need to remember about 2-dimensional arrays, and that is rows are king. Okay, rows are everything when we come to think about and construct 2-dimensional arrays in a programming language like Python. So this is so important. I've actually dug out a cartoon character picture of a king just to pop it on the slides to make it that relevant for you. Okay, so in Python, rows are king, rows are everything. And in fact, Python thinks about 2-dimensional arrays and tables in terms of collections of rows, and we'll come to this point in a bit more detail later on. So bearing that in mind again, we would say that in this particular example the value of 4 is located at 2, 3. In other words, row, remember rows are king, rows first, row 2, column 3. Okay, so that's how we would describe the position of the number 4 in this particular table. So moving on then, how can we take this idea of rows are king to understand how Python goes about constructing 2-dimensional arrays, particularly in memory, because this is very important. Well, the first thing that I'm going to do is I'm going to give my rows of my table names. Okay, so I've started off at row 0. So row 0 called row 0, and then all the way down to row 4. Now, of course, we've got 5 rows in this table, but because I've started naming my rows with 0, we've got row 0, row 1, row 2, row 3, and row 4. Why is this relevant? Well, let's compare the way that Python thinks, if that's the right expression, compared to the way that we think of a 2-dimensional array as a table. So the way that we think, of course, of the table is in terms of rows and columns, but the way that Python thinks about a two-dimensional array is just in terms of rows. It's a collection of rows. Okay, so not that much different from our own metaphor or analogy of using a table, a collection of rows. Now, with that in mind, of course, you may have recognized already, in fact, if I get my little drawing tool, you may have noticed that the Python view of a particular row looks suspiciously like the syntax for a one-dimensional array. It's a series of values in the row with square brackets at either side, and this is exactly the way that Python works. Python thinks about a two-dimensional array as being a collection of one-dimensional arrays where each one-dimensional array uniquely represents a row. And if you have a look on the slide, you can see that actually if you put the Python arrays, one-dimensional arrays, underneath each other, it's not that different in terms of the way that we think about an array, a two-dimensional array, as a table, and the way that Python goes about constructing a two-dimensional array with values. So if I just take my marker off there for a second, you can see here, if we have a look at the value 21, you can see that the way that we would talk about the value 21 is to say it's at location 0, 1. If you reflect back to what we were saying a little bit earlier on, rows are king. So row comes first, so 21 is at position 0, 1 in our table. Now, Python actually does something very similar. In Python, it basically says row number 21 is in one-dimensional array 0, at position in that particular array at position 1. Okay, so basically we're saying the same thing. It's just that Python has constructed a row using a one-dimensional array. Now, as long as we tell Python which one-dimensional array, in other words, which row we need to go to, okay, the only other thing that's left is to tell Python which index value in our one-dimensional array we want to work with. And this is why, of course, rows are king, because rows are in essence one-dimensional arrays. So let's look at another example. If I just take the marker off the screen there, let's go back to the example number 4. Okay, now we would say that the number 4 is at row number 2, column number 3. The way that Python would reflect this, if it could talk to us, okay, Python would say the value 4 is at row represented by the one-dimensional array number 2. Okay, so check that out on the screen. Python would say the row represented by one-dimensional array called number 2, and in that array it's at index position 3. Okay, so we give Python the row first, in other words, the name of the one-dimensional array, and then we give it the index value in that particular array. Okay, so if you need a little bit of time to digest that, guys, replay the last few minutes of the video and just study the screen to see how these two ways of thinking actually aren't really that different. We're just talking about one-dimensional arrays as representing rows in our table, and once we've got those ideas joined together, it becomes much easier to work with two-dimensional arrays in your program code. Okay, so we started off at the beginning of the video by saying we want a clear way to picture a two-dimensional array, and we've talked about picturing it as a table or a grid where we need to have two bits of information. We need to have the row and the column in order to be able to home in and work with a particular value in our table. And if you want to think about a two-dimensional array as a spreadsheet, that's fine too. They are all the same representation. Basically, we're talking about data in a table format. We want to understand how Python constructs a two-dimensional array, in other words, what we need to program as well. And we said that in Python, or the way that Python thinks, each row of our table is in essence a one-dimensional array. Python brings them together as a collection of one-dimensional arrays, and each one-dimensional array represents a unique row in our table. Okay, once we've done that and we represent our one-dimensional arrays on top of each other, you can see, if I just go back to this previous slide, you can see that actually there really isn't much difference between the way that we picture a row in a table and the way in which Python constructs and uses a one-dimensional array to represent each of the rows in our table. Okay guys, so I hope you have found that useful, and in the next video we'll be taking the same example of the table and we'll actually be constructing a two-dimensional array where each of the rows in our table is constructed using a one-dimensional array for each of those rows. So I will see you in the next video.